So this is the video for Part B of the June 2018 Regents exam. We have the B1 multiple choice and the B2 extended response. Let's go. So 36 begins with an estimation question, as they often do. Individual step on a staircase. So if you have numbers that are powers of 10, I would recommend writing them out so you can see what they actually are. Okay, so with the estimation questions, you can usually eliminate 2 as not making sense. 2 meters and 2 meters for an individual step does not make sense. So we either have 0.2 meters or 0.02 meters. And then in centimeters, that would be 2 centimeters or 20 centimeters. 2 centimeters is tiny, and you can see that on your ruler. When you go to take the test, you'll have a centimeter ruler. So you can see 2 centimeters is tiny, and so is definitely choice 2. All right, 37. Electrostatic force on an electron by another electron when they are 0.1 meters apart. So we did universal law of gravitation before. Now we have 2 electrons. Let's see, 1 electron and then another, and they are 0.1 meters apart. Coulomb's law. So for the charges, we have 2 electrons. The electrons are 1 elementary charge, which is 1.6 times 10 to the negative 19 coulombs. And K is 6.67. Oh, wait a second. No, it's not. That's big G. Hold on. 8.99 times 10 to the 9. Fix it. I was using the big G number. I need to use the K number. But all of those guys, K and the 1 elementary charge 2 coulombs, is page 1 of the ref tabs. All those constants are there. The formula is page 4. I think, yeah, I'm pretty sure the electricity equations are page 4. And I would also, again, use the alpha y equals when putting that, when doing like big fractions like that. But you should get 2.3 times 10 to the negative 26. And that's 2.3, not 2.30. There's only one significant figure. I'm sorry, 2 significant figures. So it's 2.3 times 10 to the negative 26 newtons, and that is going to be choice 3. All right, next question, 38. Okay, so things that we know for 38, we know the weight of the thing that is falling. We know that it's falling from rest, so V initial is 0. The vertical distance that has fell, the y displacement, I'm going to write that as negative 5.3 meters. And it wants to know what is the kinetic energy of that weight. Okay, so there are actually 2 different ways to solve this problem. One way, the shorter way that you can do it, let's see, I'm going to put the shorter way on the right side over here. So the kinetic energy gained is equal to the work that was done, and then the work that was done is force times displacement, and the force and the displacement need to be in the same direction. Now the force in this case would be the weight acting downwards, and that's the 65 newtons, and the displacement would be downwards 5.3 meters. And when you put the 2 of them together, you get 340 joules, which is choice 2. Another way that you can do that, I'm going to put it in this box right here, is say, well, I'm looking for kinetic energy, and kinetic energy is 1/2 mv squared, right? And so I know I can treat this as a free fall problem, and I can say Vf squared is Vi squared plus 2AD. Vi, falling from rest, is 0. A is negative 9.81 meters per second squared, and then D would be negative 5.3 meters. If without going through the math, when you solve that out, you get a final velocity of about negative, even though that's just a question of speed, 10.2 meters per second. And then the mass, if I know the weight, Fg, is 65 newtons, then the mass is about 1/10 of the weight, which is about 6.5 kilograms. And when you put in the mass and you put in that V final, not forgetting to square the V, you wind up with 640 joules. So that's another way of doing it, treating it as a free fall problem. I think the first method, saying that kinetic energy gained is equal to the work done, that's a much easier way of doing it. But in any way you slice it, 38 winds up being choice 2, 340 joules. All right, 39. So we're colliding, so this is a momentum problem. And it wants to know the total momentum of the two-car system after the collision. So the total, P before equals P after, and that's on the reference table. So it's asking about the momentum after, so we have to take a look at the momentum before. So we have two different carts. We have a 0.5 kilogram cart, and we have a 0.8 kilogram cart. And the 0.5 is traveling to the right, and the 0.8 is moving to the left. Sometimes it helps to draw a picture. And then they collide with each other. They would collide with each other because they're moving towards each other. And so the heavier guy is going slower and the lighter guy is going faster. And so basically my P total is going to be the sum of the two momentums, P1 plus P2. And we know that P equals mv, so that's m1 v1 plus m2 v2. And I know that the total momentum after will be the total momentum before, so I just have to add these two momentums together. So we have mv plus mv. However, the 1.1 meters per second is going the other way, and when it comes to momentum, positive and negative with directions make all the difference. That is negative 1.1 meters per second. And so even though we have a heavier car moving to the left, it still does not have enough momentum at 0.88 kilogram meters per second to overcome the momentum of the car moving to the right, which is coming in at 1.1 kilogram meters per second. And so the net result is a positive 0.22 kilogram meters per second, and that is the total momentum before and after the collision, provided there's no friction, and there is no friction, so frictionless. So 0.22 kilogram meters per second. All right, number 40. Object weighing 2 newtons pushed on a horizontal frictionless surface by a force of 4 newtons. What is the magnitude of the net force acting on the object? It does not say it's moving with a constant velocity, so the net force is not 0. And then you might say that, oh, well, 4 minus 2 is 2, so the net force is 2. However, the net force is actually 4. Now let me show you why. So we have it's supposed to be horizontal. That's a terrible straight line. Let's try that again. Okay, so that is much better. All right, so we have a box, and it weighs 2 newtons, so there's my 2 Newton weight vector, and it's being pushed by a hard force of 4 newtons. Now you can see, since they're at right angles, they can't cancel each other. And it's like, now wait a minute, it's like, what, those are 2 newtons at right angles. Can't you do Pythagorean theorem to find the resultant? Well, the resultant of those two is 4.5 newtons, and 4.5 newtons is not a choice. So why is it 4? What's going on with the 2? Don't forget that if a box is on the floor, the normal force of the floor back on the box also acts. And so in the end, the normal force and the weight cancel each other out. It's a little more complicated as to how that works. It's, again, the interaction between the floor and the box, and then the box and the earth, and whatever. I'm not getting into deep into force pairs here. Just realize that those two forces balance each other out, and so what's left over is the 4 newtons traveling to the right, and so the net force is 4 newtons. There's no friction because it says frictionless surface. And again, there's more to that interaction with the normal force and the weight in terms of force pairs. I don't want to get into the weeds on that. It's not really necessary, and I don't want to confuse people with those details on that question. So that is 40. All right. Then we have 41, and it says ratio of the wavelength of AM radio waves traveling in vacuum to the wavelength of FM radio waves traveling in vacuum is approximately what? So we're going to check page 2 of the reference tables in order to look at the EM spectrum chart. And so checking the chart, we have AM radio waves are between 10 to the 2 to 10 to the 3 meters. So you're talking about 500 meters. But FM radio waves are much shorter. So that's in the range of 10 to the 0 meters to 10 to the 1 meters. So that's from 1 to 10 meters, which is kind of about like 5 meters, whereas AM radio is like 500 meters. And so this is the ratio of AM to FM. Ratio means divide. That's about 100 to 1. And so that is like when you 500 over 5 is like 100 to 1. So 10 to 2, 10 to the 2 to 1, choice 3. Interesting way of making use of the EM spectrum chart. 42, charm quark charge has a charge of approximately what in coulombs? I'm going to look at page 3 of the ref tabs, and I'm going to find that my charm quark, not to be confused with C, the speed of light in vacuum, but my charm quark is plus 2/3 E. And I know from the first page of the reference table that one elementary charge is 1.6 times 10 to the negative 19 coulombs. And so 2/3 of that is, that's 1.07 times 10 to the negative 19 coulombs, and that's going to come in at number 2. All right. 2 more in this column on this page. 43, we have ourselves a circuit. There is one resistor in that circuit, and there's Y and there's X, and this is what are the readings on the meters. Well, first you have to know what the meters are doing, and so Y is in parallel across the resistor, and so that is a voltmeter. And then the X is in series, kind of holding hands with the resistor, and so that X right there, that is an ammeter. So X is going to be in amps, so not in volts, so not 1, not 2. And then, all right, so what are the correct values? Well, I can see there's only one resistor in the circuit, and so with only one resistor in the circuit and nothing else there, then if it's 12 volts from the battery, then it must also be 12 volts across that resistor. So Y needs to read 12 volts. And oh, look at that, how nice. Y reads 12 volts in both 3 and 4. Fine, they're going to make us find the current. Well, if R equals V over I, then I equals V over R. And so that 12 volts over 3 ohms gets me 4 amps worth of current. And so that is 4. There's a bunch going on there. You have to recognize the correct circuit placement, and then you also have to apply Ohm's law. Interesting. So that's 4. 4 on 43. 44. Toy airplane flying in a circle, 10 circles in 30 seconds. If the radius is 4 meters, what is the speed of the airplane? Well, we know that speed for something moving in a circle at constant speed is 2 pi times the radius over the period. But now we need the period. And it tells us that it does 10 circles in 30 seconds. So we can get the period from that. And we can set up like a ratio, but the period, if it's 30 seconds for 10 cycles, then it's 3 seconds for 1 cycle. So if I put in 2 pi times the radius of 4 meters over that 3 seconds worth of period, I get 8.4 meters per second, which is choice 4. So there's the first page of the problems on part B1. If you think that the B1 questions are harder than the A questions, I would agree with that. I personally think the part, I don't know that the B2 questions are harder than the part C, strangely, but I find that the multiple choice in B1 are harder than the multiple choice in A. I think it just has to do with the skills that they're assessing. Anyway, so we have 2 more pages left of the multiple choice in B1. Let's keep going. Okay, 45, we got some motion graphs, and it says vertical motion for an object falling freely from rest. So Going down the list, we have acceleration, and actually the acceleration is negative. But that would be a constant acceleration at roughly negative 10 meters per second squared. And then we have velocity. You know what? Forget velocity is negative too. This is just going to confuse you. Forget about the negative. Just make it like absolute value. Keep it simple. So acceleration versus time is constant at 10 meters per second squared. And then velocity versus time, or speed versus time, is going to be steady rate, because the slope, I know that the slope of velocity is acceleration, and we just said the acceleration is constant, so the slope would be constant. So we'd have a steady slope. And then the displacement versus time, if the velocity is increasing, then the slope of the d versus t, because the slope, we know that slope of d versus t is equal to velocity. And if so the velocity is increasing, then the slope of the d versus t should be increasing. And how does that look but a curve like so? And so the v versus t should increase at a steady rate, and the d versus t should curve upwards. And so that is choice 2. Technically, and since there's such like hair splitters on the Regents, the velocity is negative. So the speed, if that said speed versus time and distance versus time, those would be accurate. But the displacement is negative and getting larger exponentially, and the velocity is negative. So they should have shown those as negative values, and they also didn't say magnitude. So, but that's just me being a nitpicker. Those, in terms of like the d versus t and v versus t graphs for free fall, it is choice 2. So there you go. 46, throw something straight up in the air. What happens to kinetic energy versus time? So if I throw something upwards, its speed is going to decrease. It's going to slow down at a steady rate. So if the speed decreases, then the kinetic energy decreases as well. And again, this is kinetic energy versus height, not against time, but the only graph that is decreasing is this guy right here. So kinetic energy is a function of height, is going to decrease, and that is choice 1. The exchange, as kinetic energy goes down, the potential graph, if that said graph potential energy, then it would be choice 2. But if kinetic energy decreases, choice 1. Can you guys hear the bird going crazy outside my window? It's like, what's happening out there? Anyway, 47. I have a spring, it's a particle in a spring, and it says a longitudinal wave passes to the right. So the wave is traveling that way. It's longitudinal, which means that the particle vibrates. Vibration is parallel to direction. And so if the direction is to the right, then particle X will vibrate left-right, will compress and rarefact as the wave moves through, and so that is going to be choice 2. All right, next and last page in the B1s, we have 3 questions here, 48, 49, and 50, and it'll end the multiple choice. So I have 2 crests, X and Y, they're 0.3 meters high. If you superimpose the 2 of them together, so that's when they interfere, to the superposition. So actually you need to know that this is annoying. Superposition is when they interfere in the same space. Interfere. That's obnoxious. If you didn't remember that superposition means interference, then you may not have any idea how to do this problem. But yeah, in the same space, both crests X and Y, they both have a positive vertical displacement, and so when you put the 2 of them together, you're going to get choice 3. But yeah, so that's 48. 49, we have frequency against time, and it says a horn of a car has a sound wave constant frequency. Car at constant speed approaches and then moves away. So approaches and then moves away. from a stationary observer. Which graphs represents frequency versus time? So when you are approaching, this is Doppler, by the way. Doppler effect. And so when the car is approaching the observer, then the observed frequency is higher than the source frequency, but then when you're moving away, the observed frequency is f is lower than the source f. So on approach, it's going to go high then low, and so that would be frequency versus time. That would be 3. It's approaching in the first portion, and then it's moving away with a lower frequency after. The actual frequency would be somewhere in the middle, right around there. Okay, and then 50, this is 2 identical resistors, they are the same, connected in series is 10 ohms. So I have, for series, you add them up. So R plus R is equal to 10 ohms. It says, what is the equivalent resistance of the combination of the same 2 resistors when connected in parallel? So if R plus R is 10 ohms, then that each resistor has to be 5 ohms, right? And they're identical. So I said combined in parallel, we have RE, 1 over REQ is 1 over R1 plus 1 over R2. So that 1 over REQ is 1 over 5 ohms plus 1 over 5 ohms. So that's 2 over 5 equals, let me actually resolve this out because people get confused by this. 1 over REQ is equal to 2 over 5. And so if I cross multiply with the little loops, I get 2 REQ is equal to 5. 5 over 1, really. And so I divide by 2 and I get that REQ, the equivalent resistance, is 5/2, otherwise known as 2.5 ohms, and that is going to be choice 1. All right, and that is our multiple choice, but this video is for all of section B, not just the multiple choice. So let's move on to B2. So we have 51 to 65. We have ourselves a scaled vector diagram. We have 32 newtons and 20 newtons, and they're 120 degrees from each other. And it says, determine the linear scale used in the diagram. Well, I can't do that on a digital device because I can scale it however I want. So I'm going to have to cheat and look up that answer. So I can tell you that based on what I read in the answer key, those measurements should be 8 centimeters long and 5 centimeters long. So to figure out the scale used, it winds up being that 1 centimeter is 4 newtons, and they allow anywhere from 3.8 to 4.2 newtons for that. And then 52 says find the resultant of A and B. So let's use the tail to tip method where we can redraw B from the tip of A. So I'm going to eliminate B, and then I'm going to go to the tip of A, and it says it's 120 degrees. B is 120 degrees down away from A. So there's a couple of different ways I can resolve that, but basically if I set like a perpendicular line there, I know that this is 90 degrees, and so therefore this angle here must be 30. So if I set up a protractor at the tip of A, kind of going across like that, and I set up my protractor, I would find 30 degrees, mark and measure. Now in a digital scalable device, the scale can vary, but angles all stay the same, which is nice. And so if I lay down my protractor, which I'm doing right now on my iPad, I can see that right there is 0 and 30 is right there. And then I need to draw that to scale. And so I was redrawing B, that was 5 centimeters long. So I would need to draw from the tip of A, I would draw B, and I would draw that let's see, what's my scale currently at? Based on my zoom level. Okay, got it. So I'm going to draw it the exact same length as it is down below. There we go. That's B. And then of course my resultant, I'm going to make it blue just to differentiate, is from start to finish. So from the tail of A to the tip of B. That is my resultant right there. There we go. And then it says determine the magnitude of the resultant force. Probably the easiest way to do that is just to measure it with your ruler. And at the proper scale, that should come out to 7 centimeters. So working out the math on that, we have 7 centimeters using the scale of 4 newtons per centimeter. We get 28 newtons, and so we have 7 plus or minus 0.2, and so the allowable range is that's anywhere from 26 newtons to 30 newtons is the acceptable range, and that's that. It doesn't ask for anything else in terms of angles or whatever. So that was 53. Then we have a ramp question, 54 through 56. Student pushes a box that weighs 50 newtons 6 meters up the incline at a constant speed, pushed 25 newtons of pushing force. The top is 2 meters higher than the bottom, and all of those details are in the diagram. Calculate the total work done on the box by the students while pushing the box from the bottom to the top of the incline. So that right there, the work that's done is going to be pushing force times the displacement, and so that is 25 newtons. Be careful, not the weight. 25 newtons of pushing force times the displacement of 6 meters, and we wind up with 150 joules. And then 56 says, what would happen to the total work done in the box by the students to push the box 6 meters up the incline at a constant speed if the coefficient of friction between the freight box and the incline were increased? So pretty much if the friction were increased, if the coefficient of friction were increased, then the friction would increase. So yeah, with the current friction force, it takes 25 newtons to push that box 6 meters up the ramp at constant speed. If there were more friction force, you would need more pushing force, so the total work would also increase. That's the explanation. It just says describe. So all you need to say is like increase. You don't need to say why. It doesn't say explain. It just says describe. I explained it because this is a solution video and I'm trying to explain it to you, but really all you would need to say is that it increases, and that's 56. And our last set here for B2 in 2018 is this question set. Is it all based on the same stuff? No, it's not. In fact, they're all different questions. My bad, they're all together. In the diagram below, light rays incidence on a surface interface between glass and air. When it strikes the interface, some is reflected. It may draw the reflected light ray. So for a reflected light ray, your incidence angle equals your reflected angle. They're equal to each other. And so we always measure from the normal. And so if I'm measuring this correctly, I'm going to slap down my protractor and I'm going to line it up, and I see that angle is, it looks like maybe 37 degrees. So I'm going to take my protractor and measure from the normal, and I'm going to measure 37 degrees on this side and draw my reflected ray, reflecting off of the boundary and over the normal. And the answer key says you can be between 35 and 39. We do not reflect off of the normal, so don't be doing any of these things here. That is not the thing to do. erase that. I need to make this eraser larger. There. So that's my reflected ray right there. Okay, then we have the rest of these. So 5859 is pretty straightforward. They give you the current and the time and with the charge in coulombs. So all you really need to do is I equals Q over T and solve for Q. It'd be delta Q over delta T, whatever. And there you have it, 180 coulombs. All right, 6061. A spring with a spring constant of 100 newtons per meter possesses 2 joules of elastic potential energy. What is the spring's change in length from its uncompressed length? That is a strange phrasing. The spring's change in length from its uncompressed length is otherwise known in plain English as the, not the strength, as the stretch. Stretch. Solve for X. So we have spring potential energy is 1/2 K X squared, and the energy is given 2 joules, is 1/2 100 newtons per meter times X squared, and let's solve for X. And so we wind up with an X of 0.2 meters. Don't forget X is squared, so we're going to have to square root to get that 0.2 from 0.04. All right, 6263, monochromatic, which means one color, ray of light, 5.09 times 10 to the 14 hertz. Hey, look at that. That's the reference frequency for the index of refraction chart. I wonder if it has anything to do with the problem. Travels from air into medium X. Ooh, mysterious, medium X. The angle of incidence is 45 degrees, and the ray's angle of refraction is 29 degrees. Let me guess. Calculate the absolute index of refraction of medium X. I could have seen that coming. We have N1 sine theta 1 equals N2 sine theta 2. Make sure that we are in degree mode for sine, cosine, and tangent. Then we have air. Air is the first medium, so that index is 1. We have the sine of 45. Degrees. Do not forget the degree symbol. It matters. You'll lose half the points without it. N2 sine of 29, I should say 0.0 degrees. So therefore, N2 is going to be equal to sine of 45 over sine of 29. Again, being in degree mode. And we get, for an answer, we get 1.46, and there are no units for n. And yeah, that's the index of medium X. And then finally, 64, 65. By the way, these, and you don't have to cram them into your book. In fact, do not write your answers in the actual question book. The answers must be in the actual question booklet itself. If you write your work in the question book, it will not be scored, or you have to write it in your actual answer book. So be aware of that. Then 64, 65, argon ion laser emits blue-green light with a wavelength of 488 nanometers. Find an energy of the photon of this light. This was on the last test you took. So anyway, we have wavelength. I keep on saying things like this was on your last test, which is totally relevant if you're my student in 2023. But if I use this next year, it may not be in the last test, and so this video is not evergreen. I keep doing that. I have to stop doing that. Anyway, 488 nanometers is 488 times 10 to the negative 9 meters, and that the fact that nano is 10 to the negative 9 is on page 1 of the reference table, so don't miss that. And we want to know what the energy is, so we can say E equals hc over lambda. We have 6.63 times 10 to the negative 34 joule seconds, and then we multiply that times the speed of light, and we divide by that 488 times 10 to the negative 9 meters, and we wind up with an energy of 4.08 times 10 to the negative 19 joules, and that is our final answer. And that is the end of Part B for 2018, and then stay tuned for the Part C video.